you have questions for the panel that just was up here, please ask them now. Anybody?
The pH, if you do the pH thing, low, high, and middle too.
Can you either rephrase the question or people have to
You
speak
check
up?
the pH on the pH in the mud.
Yep.
You check it out in.
So the question was, did we check the pH of the ambient sediments as well as that in the experiments? Yes, we did.
And the predators are more mud, right?
Well, we only did the experiments at the sites that had the lowest pH. But there are predators in high pH muds as well as low pH muds.
So, yeah, where was the pH most balanced? In, out?
We didn't measure that. Yeah.
There's a question in the back.
Brian, you said that there was more crab on the west side of the bay than the east side. Would that be considered more of a colder temperature for having a less of crab per area than the west side, so to speak?
Yeah.
We notice that west sides on our shores are more open.
Mhm.
More water comes, and on the east sides of our shore, there's more ice
Mhm.
during the winter months. And we noticed too, down home, that if there's more ice, where crab can go in the sediments of some of the sodding areas of the marshes, it gets collapsed down on a heavier ice.
Mhm.
And when the crab lives underneath the sod, they get crushed. And we have a few less than the previous winter before that, or the spring coming. So you said that on one side, on the east side, there was a less amount of green crab, and the west side, you found more on the west side.
Mhm.
I was just wondering if there was a cold temperature, or warmer temperature basis to that.
I don't know, but I'll tell you that the east side is really kind of facing, it's more north, and so it's colder actually on the
Right.
east side where there was fewer green crabs. If we look at, just temperature that's integrated through time. So I don't really have a good reason at this point because, what we found was more crabs on the west side, but we also found fewer clams on the west side.
Right.
We found more clams on the east side. So, if you use the hydrographic reason for why there's more clams on the east side, since green crabs are under the same really kind of hydrographic regime, although they're larger when they settle, then you'd have to say, geez, if you get more clams on the east side, you ought to get more crabs on the east side. So I think it's a little more complicated than temperature and probably hydrography.
Yeah. Well, thank you, Brian.
Yeah.
There's another question here.
I was just wondering about, I've read that there's a tipping point for acidity in shell, degradation or whatever. What is that?
Well, the tipping point really is not measured as pH, but something called saturation state. And I don't know a lot about saturation state because I'm not a chemist. The saturation state depends upon pH certainly, but other factors like alkalinity and temperature. And so saturation state is just, it's like a number. And below 1, dissolution occurs no matter what you've got. And above 1 for saturation state, then you get shell accretion. That's about it. Certainly low pH is important, but ultimately at the end of the day, our shells dissolving depends upon this other thing that I'm not measuring. That's very complicated to measure. Saturation state is what it's called. Is anyone, Phil, can you help me out with saturation state at all? No, okay. So there you go. It's pretty embarrassing, but anyway, that's what it is.
We're not there yet anyway.
Them places that are dead mud, is that what you were, it
We-
used to be clams years ago, now it's dead mud?
Yes.
That's pH?
Can you rephrase, Brian?
So the question was, are the areas that don't have clams in them that we call dead mud, Did they have clams in them before? And is the reason because of low pH? And so what these studies have shown is that if you're going to call it dead mud, that's fine. But the reason why the mud is dead is, and there's no clams there, is not likely due to pH, but likely due to predation, is what our studies have shown. Okay?
One more question, Adam?
I may have missed it. Were you measuring the pH in your test plots where you had crushed shell versus sort of control sediments where you didn't? So did you see an impact in the pH?
Yeah, we didn't, we didn't see it. What we did see was that the pH in the control plots was higher. So it was more basic.
Right.
Okay, it was more basic than
Plots without shell.
than the net, the plots with shell and without shell that didn't have nets. So unfortunately, the shells, no matter what size they were, whether they were really the fine crushed ones or the oyster shell or whatever, there didn't seem to be significant differences in buffering, even compared to the control. But the curious thing here is that if you put a net out, whether it's over a plant pot or whether it's over just mud, underneath that netting, it's lower pH, it's more acidic. But yet, that's where the clams are settling. And so that's why we're saying the linkage between pH and clam decline doesn't make sense to us.